Math is a wonderful thing. Math is a really cool thing.
Okay, next we are going to learn how to find the front, side, and top view of an object. Before we start, let's try to revisit how to find a volume of a rectangular prism. Rectangular prism is a three-dimensional figure. It has a length, width, and height. To find the volume, we have to use the formula length times width times height. Now what if instead of rectangular prism, we're going to find the volume of a cube? Cube means we have the same dimension for length, width, and height. In this example, we have 1 unit. We can still use the formula length times width times height. In this case, you will have the same dimension for your length, width, and height. So if you're going to multiply your length, width, and height, you will have 1 times 1 times 1 equals 1 unit cube. Of course, the shortcut to finding the volume of a cube is just side raised to 3 because it's just multiplying side times side times side. Now, let's say we have this three-dimensional figure. To find the volume, since 1 cube is equivalent to 1 cubic unit, we just have to count how many cubes we have in this three-dimensional figure. And the number of cubes will be your volume. So in this example, how many cubes do we have? We have 1, 2, 3, 4, and 5. So the volume will be 5 cubic unit. The rest of our discussion, we are going to identify what will be the front view, side view, and top view of a given three-dimensional figure. So if you were to snap a picture of this object, what do you think it would look like from the front view, top view, and side view? I copied this 3D figure and made a model out of it. So I used my snap cubes so that we can easily identify the top, front, and side view of this three-dimensional figure. So the front looks like this. You'll only be seeing 1, 2, 3, 4 squares, and then on the side you'll be seeing 1, 2, 3, 4, 5, 6, 7 squares. And on the top, so if this is the front view, the top looks like this. So you will have 1, 2, 3, and then 4 squares. So to snap a picture of the top, front, and side view, we will have, so again, the front looks like this. You will have 3 squares. So we will have 1, 2, 3, and then this can be represented by this square. Alright, so that's your front. Top will look like this. You will have 1, 2, 3, 1, 2, 3, and then you still have this square. Okay, just so happen that the front and top view looks the same. Alright, next, what will be the side view? So side view looks like this. We will have 1, 2, then 1, 2, 3, then 1 and 2. So we'll have 1, 2, that's these 2 squares. Now these 3 squares will be 1, 2, and then 3. And finally, I have two squares on the right. Oops, two squares will be here. One and two. Alright, so that's what we're going to do in this unit. Given a three-dimensional figure, we are going to sketch the front view, the top view, and the side view. Alright, let's have our second example. So let's again solve this problem. Find the front view, top view, and side view of this figure. Now let's start by creating a 3D model of this figure. Alright, here's the three-dimensional figure of this problem. So the front looks like this. So you will have three squares at the bottom. One, two, three. And then the one on the second level is only one square. Alright. Next, for the top view, so this is the front, this is the side. The top view looks like this. So you will have again three squares. One, two, three at the bottom. So one, two, three. And then this can be represented by this square. Alright, so this is the front, this is the top. Next, the side view looks like this. So we have two squares at the bottom, and then we have one square. Alright, here we go. That's how you find the front, top, and side view of this three-dimensional figure. Now the question is, are we allowed to use snap cubes when we take our test or SOL test? Well, the answer is no. So how are we going to find the front, top, and side view of the first two examples that we discussed without using snap cubes? So we can just identify the front by counting all the squares. So for example, if this is the front view, we just have to drag, let's say identify this is front, this is front, and this is front. So you will have three squares at the bottom and one square on top. And then the top view, just have to label that's top, another top, another top. So this 1, 2, and 3 is represented by these squares, and then this is represented by this square. And finally, for the side view, remember you're just looking on this side, looking your eyesight. So this is your eye. Are just looking on this side. The only figures that you're going to see will be, so you will have side and side, which is these two squares. Now the other side, which is this, is above the first square to the left. So to represent this, just draw or shade this square, and this will now represent the side view of this given three-dimensional figure. Example number 2, pause the video and find front, top, and side view of this 3D figure. Alright, so for the front, we can label first all the front square or the front image. Front here, we have front, I have two. We have two squares. The first column, we have two squares, and then this can be represented by this square. And then looking at the top, so I have one and then two. So again, it's like you're looking above this figure. So you'll be seeing this square and this square. And we can represent that by putting two squares. Next, note that we have also a square here and another square. So we have another column or another row. So to represent that, have this square and this square. Alright, finally side view. Your eyes will be located here. You're looking on this side. Okay, so let us represent side view and another side view. So we have two squares and we can represent that using these two squares. Next, we also have this square, which is to the right of this square, represented by this. So just move. Alright, there we go. And that will be our side view. Alright, for questions 3, 4, 5, and 6, I need you to pause the video and find the front view, top view, and side view. Alright, I hope you pause the video. We'll discuss or we will compare answers in class tomorrow. Okay, what about the opposite? Let's say given the different views below, the front, the top, and side view, can we build a three-dimensional black figure?
Let's start by creating a three-dimensional figure. I think we can start by looking at the top view. So we have like a cross. Let's try to create. So we have this, and then okay. So we already have the top view. Now, for the front view, it says we have two levels. And it should consist of 3 squares at the bottom and another 3 squares on top. So it seems like I can have if I have it like this, okay, so the front view, okay, this will do the front view of the figure. If you look at the top view, still across, so we're good. Now, this is the front, this is the top. When you look at the side view, we need to have also 2 rows. Seems like I need to put something in here. Alright, I think this will do our three-dimensional figure. If this one is the front, I have 2 levels of squares, 2 levels of 3 squares. 3 squares at the bottom, 3 squares on top, on the second level. Top view, we have a cross. And then, when you look at the side view, alright.
Okay, let's start by drawing the view, which is we have 3 squares. 1,
2, and then 3. We have this square. Okay. And since we know the front view should consist of 6 squares. Just okay. Alright. Okay, I think this will do the
answer. So this will be the three-dimensional figure having a front, side similar to this, having a top view, and having this as your side view. So your top view will be this. A front view, we can take this as your front view. We have 1, 2, and 3, which is this. Then we can see the other one at the back, but there's one there. front, which are these three squares. And for the side, we'll have 1, 2, and 3 on this side. Another 1, 2, and 3. So this will be the three-dimensional figure. Alright, so go ahead. Given the following front, top, and side view, find the three-dimensional figure that corresponds to these views. I hope that you were able to draw the three-dimensional figure. Go ahead and do the rest, and we'll compare answers in class tomorrow.
Math is a wonderful thing. Math is a really cool thing.